Austin here, and in today's video, we're going to review the different formulas that you were introduced to yesterday on finding the volume of a cone, a cylinder, and a sphere. All right, so you should have in front of you this little foldable, and I'm going to lead you through how to make it because this little thing is going to come in handy as you study for this Friday's quiz over volume. All right. So the first thing you're gonna want to do to get started is you're going to find the dotted line. So you're going to find that little dotted line right there, and you're going to fold it on that dotted line. All right. So I'm gonna do mine. All right. You fold it. You're gonna want to crease it, and then you're gonna want to tear it off. We want to tear that little part off. I'll give you time to do that. All right, now that you got those torn off, it should look like a square. And now we're going to get to folding it up. All right, so the first thing you want to do is you're going to want to take the one that says circle. All right, you're going to put it down on the table, and you're going to want to fold it in. All right, you're going to fold that part in. And you're going to do that to all four corners. All right, I'm going to do the circle. And then I'm going to go over to number 2, the cylinder, and I'm going to fold it in. All right. And then I'm going to fold in. So right now I'm at this point. I'm going to do the same thing with 3 and 4. I'm going to just fold those in. Boom. That's the cone. And now the sphere. So you should end up with something that looks like this, and we've made similar foldables like this, and we're going to take our notes on the flaps here, all right, for each problem. So you should end up with this, and once you get that ready, you'll be ready to start taking your notes. All right, the first thing we're going to start with is going to be the circle. And I know you probably didn't cover the circle yesterday, but I think the circle is a good place to start because it's a two-dimensional figure, and all of the three-dimensional figures that we're going to be studying this week, the cone, the sphere, and the cylinder, all of the formulas for volume that we're going to study are based on the formula for the area of a circle. All right, so we're going to start off just reviewing that. You touched on this in previous grades, but I just want to refresh your memory. All right, so right here you should see the word problem, and it tells us to find the area of the circle shown. Use 3.4 for pi, and that's just a rough estimate. Remember, pi is an irrational number, so it goes on forever. But we're just going to use 3.14 for the purposes of this foldable. But always remember that that's the same thing as pi. And we're going to round to the nearest tenth if necessary. All right. So the first thing that it starts us off with is the formula that the area equals pi times the radius squared. So you square the radius and then you multiply it times pi. All right. So we can see here in our picture, our radius is 5 inches. And remember, radius is the distance from the center of the circle to the outer part of the circle. All right. And now we just plug in. So for pi, we put 3.14, and then we square the radius. 5 squared, we get there, we get 25, because 5 times 5 is 25. And then we multiply that times pi, which is 3.14. And our answer becomes 78.5 because we round to the nearest tenth. And remember, our units are inches squared because it's a two-dimensional figure. A circle is a flat figure, so it only has 2 dimensions. The rest of the formulas we'll be talking about will all have 3 dimensions because volume is a measurement of 3 dimensions, whereas area is just the measurement of 2 dimensions. All right, so copy this part down on the inside flap of your foldable. And then we'll move on to the cylinder. All right, the next geometric figure we're going to look at is talking about volume now. All right, so circle, we're just talking about area. These next three, we're talking about volume. And remember, volume is like a measurement. Think about filling up a swimming pool with water. That'll be volume, or how much liquid can a jug contain. That'll be volume. So let's look at this cylinder. And we're going to figure out what is the volume of this cylinder, or how much liquid or water or material can this cylinder hold. All right. So number 2 says find the volume of a cylinder shown, and we're going to also continue to use 3.14 for pi. All right, but we could always leave that as pi. And we're going to round to the nearest tenth if necessary. All right, so we start off with our formula. Make sure you get the part in red down into your foldable. And volume equals pi r squared times the height. All right. And here we see that the radius of the base of this cylinder is 5 inches. So you always take the radius of the base, the circle part. All right. And the height is just how tall it is. And in this case, the height is 12 inches. And we just plug those in to the formula. We plug in 5, square it, and then we plug in the height here, 12. All right, and then we multiply that out. And in most cases, I looked this up on the Georgia Milestone, you will be able to use a calculator. So you can use a calculator to work this out, but it shouldn't be too hard to work it out by hand. So 5 squared, we know is 25. All right. And then if we multiply these three numbers together, pi times 25 times 12, we'll get 942 inches cubed. And notice this time it is a 3 because a cylinder is a 3-dimensional shape. All right, so volume is always in cubic units. So that is the way you solve a volume of a cylinder problem. All right, the next shape we're going to look at is going to be a cone. And same thing, we always start off when we're trying to calculate the volume is we start off with the formula. So the formula for the volume of a cone is V equals 1/3 pi r squared times the height. All right, and again, we look up here at our picture, the radius is 5, so that's our R. The height is 12. Remember, the height is always just going to be a straight up and down line. So don't let this 13 fool you. They're going to try to do that a lot. So don't let that 13 fool you. That is not the height. The height is that straight up and down line that goes straight from the base to the very top of the cone. That is the height. So we plug those in. The radius squared, which was 5. 5 times 5 is 25. We multiply that times our 12. And then we multiply it times pi. So we get 1/3 times 942. And remember, anytime we take a third of something, that's the same thing as dividing it by 3. So here we take 942, we divide it by 3 because that's the same thing as multiplying times 1/3, and we get 314. And don't forget to put your inches cubed as your units. All right, we're about to move on to our last one. All right, the last geometric figure we're going to cover today is going to be the sphere. And the sphere is just think of a ball. Think if we were trying to calculate how much air a ball could hold, we would use this formula. So the formula for the volume of a sphere is V equals 4/3 pi r cubed, so the radius cubed. So the only dimension we need is the radius of the sphere. So we plug that in. The radius here was 5. 5 cubed is 125. I multiply that times my pi, which is 3.14. All right. And then at the very end, once I multiply this, I just multiply it times 4/3, or 4/3 times 392.5. All right, and then I get my final answer, which is 523 and a third.
Gonna make a change for once in